So don't get bogged down in the detail. I want you to know the categories: the phenolics, the tannins, the catechins, the anthocyanins. So the phenolics, the big group, 3 categories. I want you to know those groups. And I think the previous slide, I think, is a good summary of phenolics. Know this. Know the primary constituent or character of those phenolics. But don't get caught up in too much detail, which will be presented. Tannins are polymeric forms of phenols. Polymeric, a polymer, means that they're joined together in some sort of chain. And anthocyanins are included in these polymeric phenols. Phenolic compounds vary depending on the variety of the grapes, the temperature, the alcoholic concentration, and the time of contact, specifically skin contact. And how they're extracted, how these phenolic compounds are extracted from the skins depends on the temperature at which you are performing the fermentation, the maceration time, we'll get into maceration in just a second, the agitation or mixing process, the alcohol or ethanol concentration, and the SO2 concentration. Now, ethanol is a type of alcohol, and we talk about alcohol in winemaking all the time because there's only one alcohol, ethanol. Alcohol is a very generic category of chemistry, and there are many, 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 many chemicals that are called alcohols. There is a certain structure that I won't get into, but there is a certain structure that if a molecule has that structure, it's called an alcohol, regardless of the other parts of the molecule. And some alcohols are things that we might use, like isopropanol or isopropyl alcohol, which is what you might have in your bathroom, rubbing alcohol. And that is not something that you drink. It's something that you use for various purposes in your home and for health and beauty care. And maybe you use isopropyl alcohol, rubbing alcohol, maybe you don't. If you don't do fermentation, not fermentation, but if you don't do distillation properly, not a problem in winemaking, but a problem in perhaps whiskey or moonshine making, you can actually make methanol, methyl alcohol, or methanol, sometimes called wood alcohol, which is toxic. It kind of tastes like the drinking alcohol, but methyl alcohol or methanol will cause you to go blind and can even kill you. So you got to be careful when you're doing distillation that you know what you're doing and you don't make wood alcohol and kill people. Ethanol or ethyl alcohol is the kind that is in human beverages, adult beverages. So wine, beer, and hard liquors contain ethanol or ethyl alcohol. So just to get that clear. Maceration is the process of soaking crushed grapes and seeds and stems in a wine must to extract the color and aroma compounds as well as tannins. So maceration is a breakdown of the cellular tissue. Things fall apart. Another way we use the word maceration is chewing. I take a bite of apple. What's the first thing I do? I macerate the apple with a physical maceration process called chewing. And my molars come together and squish it up and break down those cells, releasing the wonderful flavors and nutritional components inside of that apple. I'm macerating it to release the materials that I want in my mouth and in my stomach. If I were to take a bite small enough to swallow and I just bit it and swallowed without macerating it first, well, I might not get as much out of it nutritionally, and I certainly am not going to get as much out of it from a flavor experience. I'm not releasing those materials. Yeah, they'll get macerated in my stomach. An apple probably would get macerated pretty dang well, but some food wouldn't. Certain things you need to pre-macerate with your teeth. Okay, so understand the concept of maceration is the breakdown of cells, the breakdown of material, releasing what's inside. So maceration in grapes, we don't actually have to do anything else. We're not chewing it. We're getting some maceration during the physical crush and press processes, but if I've got a red grape, I'm not pressing it yet. I just crushed it, and that does some maceration. Now we just let it sit under certain conditions, and we let biology continue. There's all these enzymes, and they're like molecular teeth. These enzymes are breaking things down, tearing apart cells, breaking down chemicals, and maceration is occurring at the molecular level, releasing things like the colors and flavors in the wine skins, in the must. And so the maceration time is really important. How long are you going to let maceration occur for the extraction of color and flavor components, aromatic components, into that wine? So phenolics are antioxidant compounds. That's good. They are reported to have health benefits, also good. One of the reasons why a lot of people think that a glass of wine a day or night is actually good for health. Now, a 54-ounce glass of wine is not what they're talking about. You know, you don't take the 2-liter jug and call that a glass of wine. A glass of wine is 6 ounces, which is pretty dang small. That's half a soda can. Half a soda can is a glass of wine. And the phenolics are very, very, very low in white wine. So all of these health benefits, it's not as evident or pronounced in the whites. We see that in the reds, where we're getting these phenolic compounds that are most correlated with health benefits. So somebody who has a 4 or 6 ounces of wine with dinner, there's a lot of evidence in the European appetite where that's a good thing. Now, you can't counteract a bad diet. You know, I'm going to have French fries and red wine for dinner every night. That ain't going to cut it. But with other good, healthy eating habits and daily habits, you know, 4 or 6 ounces of wine a day, actually, there's some evidence to show that can be healthy. There's some evidence to show that maybe the alcohol isn't necessarily healthy, or maybe it is healthy. And, you know, there's a lot of back and forth in terms of what the literature says about our diet and our health. Now, certainly, I think it's pretty consistent that the phenolics are being shown as a good thing. Phenolics provide natural microbial defense mechanisms for plants. As I mentioned in another lecture, they are pesticides for the plants. For us, they are color and flavor components. The catechins are highest in the seeds. They provide an undesirable flavor if they are in excess, because they can be very bitter. And a tiny bit of bitterness, especially in certain types of red wines, is a good thing. How much do you push that bitterness? It depends on your customer base and the type of wine you're after. You push it too much and you're going to cause the pool of potential drinkers of that wine, consumer, is going to go down, because a lot of people don't like the high bitter. So if you have less bitterness, you might cast a broader net, not enough bitterness, and maybe you don't have the varietal characters and you've got kind of a bland wine. It doesn't have that character that you really want. So there's a balancing act. You can use gentler presses that will avoid breaking the seeds and getting these excess catechins into your wine. Catechins are produced in higher amounts when vines are under disease stress. So catechins tend to be higher in cool, damp climates. How much of that is because cool, damp climates are also perfect for fungal diseases, and how much does the cool, damp climate have an impact directly on the chemistry inside the grapes? Don't know for sure about that one. The contact time, there's 3 different categories. No contact, you get the juice pressed and separated away right away, and you have no contact with the skins. You can have a short contact, 1 to 4 hours. That increases the varietal character at the risk of getting some phenols that maybe it's what you want, but you've got to be careful. Too many phenols is, for most white wine types, varieties, or products, you're not wanting too much. The long contact, up to 24 hours, that gives you the maximum varietal character, but you're getting high phenolics. And so you have to decide, with that type of white wine grape, is that something I want to do or not for the product I'm making? But you don't leave them on for a long period of time. 24 hours is considered a long period of time with white wines. With reds, you're barely getting started. So very, very different contact time scenarios. And if you're using a red grape, you might treat a red grape with a white wine making process, where I have the red grapes with no contact, well, that's the bleed we talked about earlier. Or you might have a short contact to get a little bit more of that red color. I don't know that anybody uses a long contact of 24-hour contact, although it might be used. I have limited winemaking exposure, but most of the things of which I've been aware, that I've talked to people about, when they're using red grapes in a white wine process, they either have no skin contact or very short. Longer contact regimes, or regimens, I should say. That's the wrong word there. Not my PowerPoint, but I never caught that. A regime is different than a regimen. A regimen is a process. But anyway, longer contact regimens should include increased sulfur dioxide usage and cooler temperatures in order to counteract those phenolics. There's also hyperox. We talked about polymerizing the phenolics. So again, I'm not going to go into the detail there, but you can deal with the phenolics in different ways. Underripe fruit will have less ripe tannins, which give you a bitter flavor. So if you've ever eaten underripe grapes, you know that underripe grapes are very bitter, and that's not good. Maceration with underripe fruit or specific varieties may yield bitter and astringent character. So you got to be very careful with underripe fruit. You really have to be careful about being gentle and only getting the juice without extra skin and seed influences, because the skin and seed is going to compound the problems from the underripeness. But there are some varieties that are intended to be bitter. So such as the Muscat, Emerald Riesling, and some others, they are intended to be bitter whites. That is their goal. But bottom line, maceration should be shorter on bitter or green grapes in general. What about red grapes? All right, destemmer to the must pump. So now I've got the must, skin, seeds, and juice, the must. Maybe you'll go to a cold soak process. I'm not going to get into that, but that's another choice. There's a question mark here because that's just an option for certain styles or processes of making a red wine grape. So color pigments are mainly monomeric, meaning they're not chains. We have monomeric anthocyanins, single anthocyanin molecules, rather than polymerized anthocyanins. And this is a note to the author, I'm sure. Draw a red color extraction curve versus the tannins. Doesn't matter. There's plenty of information out there about extraction patterns with skin contact maceration times. And you can look up all kinds of information on how different maceration skin contact techniques and durations and temperatures will impact the extraction of every conceivable compound you're interested in. But the maximum, pretty much no matter what you do, whatever wine process you're using, a skin contact of 3 to 5 days, you've pretty much maxed out everything from a color standpoint that you can get out of those skins. So again, what was the maximum for whites? 24 hours. And here for reds, you're doing 3 to 5 days potentially. Pressing early may maintain color without the tannin accumulation. So you're pressing before the sugars have been eaten up by the yeast. When it says before 0 degrees Brix, you're not waiting for the yeast to be done turning sugar to alcohol. You're pressing those grapes before the wine is done, before the fermentation is over. You take it out of the fermentation tank, you press it, get the skins out, put it back into the fermentation tank, and let the fermentation continue. The later rather the pressing, if you go all the way to the end of the fermentation process before you decide to press, you are going to get higher tannins. So here's some anthocyanin and tannins showing the parts per million of each during the fermentation process. Again, just for your benefit, you can look at this, but I don't need you to understand this for the class. You can see here that pretty much by 5 days, the level of color has maxed out already. You're not getting any additional color. You're actually losing some color towards these later days. But most of the extraction of color happens within these first days. And this is just one example of one grape with one cold soak process. So this is just an example, but you can see how the tannin levels keep climbing dramatically after that day 5. Very low here. I've got all the color out with very low tannins at day 5. So if I separate out the skins, if I press now, I'm going to stop the extraction of tannins because the skins are gone. I took them out, threw them away. But if I want more tannins, I leave it on longer. How much tannin do I want? Do I want a very high tannin wine? Or do I want something much lower tannin but still retain the color? Again, that's the kind of message I want you to see from a graph like this. Not to memorize it, not to totally understand what's going on here, but to see the difference in extraction rates and how you can influence the balance between color and the mouthfeel flavor influence of tannins. 3 types of skin contact: no contact, short contact, long contact. Just like in the whites, you have the range. Now, long is a hell of a lot longer than in the whites. But skin contact regimens, again, largely based on the wine style being produced. There is something called thermovinification, and it uses heat to extract color from the skins before fermentation. So again, that's going to change the extraction curve. I don't know anybody who has used it. I've heard talk about it, and I'm sure it's being used. None of the winemakers I've talked to have said, oh yeah, we use thermovinification to make our blah, blah, blah wine. But I know it's out there. And so before fermentation even starts, you heat it up to pretty dang warm. Remember, 100 C is boiling, so 80 C is pretty dang hot. You jump into an 80 C hot tub and you're dead. Even 40 C is very uncomfortable. 40 C is a pretty dang hot tub. It's not going to kill you, but it's going to be uncomfortable for most people. No, maybe that's not true. Maybe it's a pretty warm hot tub. You could get used to it, but you put your toe in 40-degree water, it's pretty warm. It's pretty warm. Carbonic maceration. They call this the Beaujolais Nouveau winemaking style, and they use a carbon dioxide gas. Got to be careful. High concentrated carbon dioxide gas is lethal if you breathe it in. And it's not because it's toxic, it's because it will displace oxygen and you will suffocate. And so you've got to be careful in your operations if you have high amounts of carbon dioxide, that you don't suffocate somebody. But that's always a problem in winemaking, because what is the fermentation process doing? It's taking sugar and turning it into alcohol, and in the process, releasing carbon dioxide gas. So inside of a fermentation chamber, after fermentation has been going for a while, there is a lethal amount of carbon dioxide gas. If you stuck your head in there and took a deep breath, you'd pass out, fall into the chamber, and die. So you do have to be very careful in a winery environment and realize that carbon dioxide is in high concentrations in the fermentation process, and you must use proper knowledge and safety practices. Now you're just adding an additional process, this carbonic maceration, where you're intentionally pumping high amounts of carbon dioxide in order to macerate in an extremely low oxygen environment. Grapes' own enzymes produce ethanol until about 2%, which is pretty low, but there is some alcohol production even without yeast. The enzymes of the macerating, decomposing grapes, as they're decomposing without any yeast, some of that will turn into ethanol in the carbonic maceration process. And the pressure of the grapes squeezes the berries until they break the skins and start to press even further. And then the indigenous or natural yeast that's on the grapes, that's in the environment everywhere, will take over. Again, it's a carbonic maceration process, a very interesting style. I don't know where it comes from, but it's another way to macerate the grapes and have the contact time with the skin for a week or two. Free run and press run. I think I used the word free run in an earlier lecture, but when you press, there is the liquid or juice that flows without any pressure being added from the press itself. And we call that the free run. The free run or free flow press. So the pressing is done on unfermented must in white and blush wine production. So you haven't fermented yet, you press it right away. It's not fermented. At the latest, maybe 24 hours of skin contact time, and then you go to fermentation. Red wine, the pressing is carried out during or after fermentation. You could do it after 3 days to get a lot of color, but not all of it, and very low tannins, 5 days to have a lot of color, still low tannins, or even later than that, or go the entire fermentation process. The free run portion is the fraction that comes out with little or no pressure applied. The press run requires additional pressure, and you got to have some sort of a device, a bladder or a basket press or some other thing pushing down on the must, on the skins, on the pulp, on the seeds, squeezing out like a sponge any juice that's remaining mixed in with the skins, pulp, and seeds. And that press run, because you're squeezing the skins and pulp and seeds, you're getting more of those varietal characters coming out with it, the chemicals that are characteristic of the variety of grape you're pressing. You're getting more of those phenolics in particular. And if you overdo it, you're getting too much of the catechins out of the seeds, and you end up with something that's really bitter. So the free run volume is a percent of the total juice that you get. If in an unfermented must, so when you just are pressing the unfermented grape juice with skins and seeds, you'll get about 80 to 90%. In fermented, it's 90 to 95% of the juice comes out. So you need to add additional pressure in an unfermented must to get the remaining 10 to 20% of juice in there. So you can look at it the other way. In an unfermented must, we have to add additional pressure to get the remaining 10 to 20% of our juice out. That's a lot. You're going to want to press. I don't want to waste 10 to 20% of my juice. So you apply pressure to get the rest of that juice out. Now you might keep the free run and the press run separate from each other and use them differently or blend them back together at a certain rate to get the kind of quality product you want, or make multiple products. With a fermented wine, 90 to 95% is going to flow out without any pressure, extremely little pressure applied. And you want to get the last 10 or 5% out, you've got to put pressure on it to get that last 5 or 10%. And that last 5 or 10% of the juice coming from pressing is going to have additional phenolics and varietal characters. So the press run is higher in phenolic content, as I just mentioned, and higher in varietal character, saying exactly what I just said. Free run is higher in acidity and lower in varietal character. The press fractions are often kept separate. The pressed juice contains more pectin than the free run. Now, we haven't talked about pectin. I'm not going to talk about pectin, but it is another component that's in a lot of fruits. Pectin is what helps your apple pie stay nice and firm when you bake an apple pie. The pectin in the apples gives it some firmness when you bake it, but I'm not going to talk about it in wine. Pectinases are used to aid in settling of wine. Pectinases are enzymes that break up and get rid of the pectins and help those pectins to settle and other components to settle, because you don't want those in your white wines. Press technology. I'm going to take a break and we'll come back and look at some press technology.